Hi, in this video we're going to look at how to create a binary tree data structure in Python. We're going to use an object-oriented approach to create a binary tree, to traverse through it, and to research or to search for specific values in it. This is not meant to be a detailed tutorial for beginners because this project assumes a basic understanding of several concepts in Python. So let's get started. So here on the screen you see a visual representation of the hierarchical structure of a binary tree. This is what we're going to have in mind as we begin to develop the application for storing, arranging the nodes in a hierarchical manner, and then storing values in this tree. So the first thing we're going to do is we're going to create a class. We're going to call this class node, and we're going to define its init method. We're going to say self. It's going to take a value, a left node potentially. We're going to set it up with the default value as none. A right node. We're going to also use a default value of none. The reason why I'm doing this here this way is because when we instantiate this particular class, we may not have a left node and right node right at that time, and we still want to be able to create or instantiate this object just with a value. So self.value equals value, self.left for short equals left node, and self.right equals right node. That's pretty much it with this class here. So now we're going to create a second class. This is going to be called binary tree, and this is the class that's going to contain all the nodes of the tree. So I'm going to create another cell here. I'm going to call, class. I'm going to call this one binary tree. And then I'm going to define its init method. And this tree will take a node as an argument. So we're going to call the variable here root, self.root equals this particular node. So this is an actual node that's going to be passed into this binary tree class when we instantiate it. Alright, so moving along. I said that with this particular program we're going to be able to traverse through the tree. So I'm going to create a method here now to traverse through the tree using pre-order sequence. So this is going to be def. We're going to call this pre-order self. This is going to take a start node, which most likely is going to be the self.root, and then a traversal string. This traversal string is going to keep track of the values for this particular binary tree. So we're going to check to see if there's a start node. If there is, then we're going to do the following. We're going to grab the value of the start node and assign it to the traversal variable. So I'm going to use enough string here, and whatever value that's going to come out of the start node is going to be probably a number. So I'm going to make sure that this is a string because I'm putting everything into a string as an output of this particular method. So I'm going to say start node dot value, close parentheses, and then I'm going to create a space and a hyphen to separate the values they're going to be added to this traversal tree variable. Excuse me. So now we're going to be using recursion to actually go through all the left and right nodes of this binary tree. So traversal, in a pre-order manner, we're going to first look at the first node, the root node, and then the left node and the right node. So now we're going to use the same approach here. Traversal equals self. So using recursion here now, I'm going to call the same method, pre-order, and I'm going to say start node dot left, and I'm going to pass the traversal variable that already contains the value that's going to be grabbed at this line, in this line right here. And then I'm going to do the same thing for the right node. So using recursion, I'm going to say start node dot right, and then traversal. Now all we have to do is to return this traversal variable like that. So this one is done. The next one we're going to do will be in order. It's going to have the same signature as the previous method, and we're going to check to make sure that there's a start node before we run through the code. Okay. In an in order fashion, we're going to first grab the left node, then the root node, then the right node. So this is going to be the order we're going to do this. Traversal equals, again using recursion, self. We're going to call it self. The method is going to call it self, and then we're going to pass in let's see, start node dot left, traversal, same as above. Now in this particular line here, we're going to grab the value. So this is going to be an F string, and then in the curly braces, I'm going to again use the str function to make sure that the value that's passed in as a number gets transformed into a string. And then we're going to call start node.value. Again, I'm going to create a space and a hyphen here just to separate the values. And traversal equals self dot in order start node dot right now, and then the string variable traversal. Like before, we're going to return traversal. Okay. Next, we're going to define a method, post order, and again we're going to take on the start node and traversal string. We're going to check to make sure there's a start node, same as before. Alright. In the post order traversal, we're going to check the left node, the right node, and then the root node. So we're going to do like this: traversal equals, again using recursion, the method is going to call itself, post order, we're going to pass in start node dot left traversal, and then now we're going to go through the right node, again using recursion, the right traversal, and finally on this third line here we're going to grab the value from the root node, equals, I'm going to use an F string. I like using F strings. I think this is a great addition in Python 3. Again using the str function to grab the value from the start node dot value, a space and a hyphen just to make sure that the values are not all jumbled up together. And now I'll return traversal just like we did before. Finally, we're going to look at another method. This one, instead of this one, what we're going to do is we're going to go through the tree level by level on the left to right order. So we're going to start with the primary level here, where we see value number 1, and then we go to the second level, which has value number 2 and 3, and then 4, 5, 6, 7. So the output of this particular method is going to be 1, 2, 3, 4, 5, 6, 7 in order. So we're going to define the method here. We're going to call it level order. Same signature as before, like this. And then let's see, because this method is going to use a different approach to get to each node, we're not going to use recursion. So I'm going to pass right now because I'm going to create a class. I'm going to call this class Q, and this Q class is going to keep a list and a sequence of values that we're going to be collecting from this binary tree in order to print it at the end. Again, we're not going to be using recursion in this particular method. So let's see. I'm going to create this class all the way up here. One more code cell here. I'm going to move it up. I'm going to call this class Q. Define its init method. Self. This one is not going to take anything as a parameter. All I'm going to have here as a property is going to be a self.items, which is an empty list. So in this class, I'm going to need a method to put items in a queue. So I'm going to call this enqueue, and in order to add the item to the queue, I'm basically gonna add this item to that list. So self.items. So instead of using add or something like this, I'm going to use insert, because this particular item has to be in a certain position in the queue, like position 0, the first one on the left, on my left here. So we're going to put the items here, and then that item is going to move to the right as we put another item here, and then move to the right as we put another item like here, like this. And then once we start taking items from this particular queue, we can start taking from this end here. So we'll be using a first in, first out kind of approach here. So I'm going to say insert at position 0 this item. That's it. Also, we're going to need a way to dequeue an item. So I'm going to say dequeue, and we're going to use the pop method to get this item out of the queue. So self.items.pop. Just to be explicit here, I'm going to indicate here that we're looking at the rightmost element of that queue. That's the one that we taking out every time. Because pop returns a value, we're going to have to capture the value here. I'm going to say we're going to return that value to the level order method down below that's going to be calling this particular making use of this particular class here. Alright, so we're popping the rightmost element of that list and returning it. That's all it's doing here. And we need a method to get an item from this queue. So we're going to say self, and I'm going to say return self.items, and then I want again the rightmost element. So so before we dequeue an item, we're going to grab that item's value, and that's why we need to use -1 here on that particular list. We're going to grab the rightmost element of that list, and then but what we need is the value, not the node itself. So I'm going to do dot value like that. Finally, just to make the coding a little easier, I'm going to modify the built-in len function. So when I call it next time, it's going to return to me the length of the self.items. In other words, the number of elements of the list, or the number of the elements in the queue. That's the same thing. So that's pretty much it. That's it for this particular class. Alright, I'm going to run these classes right now, make sure that everything runs perfectly without any errors. Let's see. Okay. Everything seems to be fine. So now we're going to start instantiating these classes. I'm going to instantiate a class, binary tree class. Binary tree, okay. And then it calls for a node. So what I'm going to do is I'm going to instantiate a node class, an object inside as a parameter. So I'm going to say node, and the value of that node is going to be number 1 because that's the root node right there, like this. So now we're going to grab these two values in the next level here. So we're going to say tree.root, because now we have that value of 1 as a root. Well, that node has that value. And what I'm going to do is I'm going to say root.left equals node 2, just like that. And then tree.root.right, as we can see here, we're going to create a node with a value of 3. Next level, tree.root.left, because now we want to grab these two values over here, 4 and 5. So I'm going to say node 4 for the left one, and then tree.root.left.right equals node 5, just like that. Finally, we're going to do this section over here, so 6 and 7 specifically. So we're going to say root.right, which is the right node there, number 3, dot left, which is number 6, equals to node 6. So as I'm writing these things over here, I'm looking at this diagram here because this is guiding me in how to arrange the data and the values in this data tree. Tree.root.right equals to node 7, and we are done with this particular tree. I'm going to run this again, make sure that it runs without problems. No problems at all. So now we're going to create another code cell here. So what are we going to do now? Oh, we need a way. We're going to finish the level order method. We didn't finish this method over here. I totally forgot about it. So we created a class called queue but never used it here. So this is the level order method, the one that goes level by level, left to right order. So the first thing we're going to do here is we're going to instantiate that class queue like this. We're going to call it queue. Good. Just like that. And then now that we have the object queue, I'm going to enqueue the start node here that's going to be passed to this method. So I'm going to say queue.enqueue start node. Alright, and then I'm going to say the following. create a while loop here. While the length of Q is greater than 0. In other words, while there's still elements in the queue, I want this code to do the following. So we're going to use a traversal, this traversal string that's going to be passed here, and we're going to do the following. I'm going to use an F string again, and now I'm going to again use the str function, make sure that whatever value I grab here is going to be a string, not a number. And then I'm going to call Q's get item method that we defined above. Okay, that looks good. And then, just like we did before, I'm going to create a space here because we don't want the items to be, the values to be all on top of each other. So we want them spaced and organized. And then, okay, once we put the item in a queue, once we take the item out of the queue, because we're processing it now, then we got to delete that item. So we don't access the same item more than once. So what are we going to do? We're going to say q.dequeue the rightmost item, as we've seen before. What else? Well, since we are dequeuing, and there's a return value here, we're going to capture that return value. So we're going to call this variable deleted node. So whatever item we delete, that item is going to be captured in this particular variable here, deleted node. And then now it's going to be useful to us because I can say, well, if deleted node dot left, so if there's a left node to this deleted node, then we're going to enqueue that node. So enqueue deleted node dot left. And then in the same fashion, if there's, we're going to check to see if there's a deleted node right. Deleted, in other words, if that deleted node has a right node, deleted node dot right, if there's one. If there's a right node, then we're going to also enqueue that one. Deleted node dot right. I'm typing fast here, so hopefully there's no typos. Alright, so if there's a left node, then we're going to enqueue the left node. If there's a right node, we're going to do the same thing. And I think that now we're pretty much getting to the end here of this particular method. So we're going to return traversal just like we did before. Alright, so now we're ready to test each of these methods, make sure that they return the values of each of the nodes in a binary tree. So we're going to come down here again, and now I'm going to say I'm going to call the print method of the print function tree dot printed. It's not showing up, so what I'm going to do is I'm going to run all of these again, and now I'm going to try again. So tree dot printed. Oh, I haven't created a printed tree yet, so alright, so I'm getting ahead of myself here. So instead of calling each of these methods individually, so we have level order, we have post order, we have in order, and pre-order. Instead of calling them individually, we're going to have a method that's going to return to us the method that we want to use at that particular time. So I'm going to call that method, I'm going to define it down here, I'm going to call it print tree. So I was trying to call this method here before defining it. So as a parameter, this is going to need just the name of the traversal type the user wants to use. So I'm going to say, I'm going to call this here trav type for traversal type. It's a string variable. What I'm going to do is, if I'm going to use an if statement here, if the traversal type dot lower, because I want to make sure that we don't get any errors just because the user capitalized one of the letters in the name of the traversal method that he wants to use. So we're going to turn everything to small caps. So if traversal type equals to pre-order, all I'm going to do is return that particular method. So self dot pre-order, and then I'm going to pass into it the self dot root, because all of these traversal and later the searches, we're going to use the root as the starting node, and then we're going to pass in empty string just like we did before. And here, because all of these methods they return a variable containing the values of all the nodes separated by hyphens and spaces, it's going to look in between the numbers, but then at the end, the last number, after the last number, we're going to have a trailing space, hyphen, and space. So we don't want that. So what I'm going to do is I'm going to do a slice in here of this string, and we're going to remove the last three characters here of that string. Alright, so elif traversal type dot lower equals to in order. Then we're going to return the appropriate method. We're going to return in order. We're going to pass in the self.root just before, empty string, and also we're going to do the slice in the same manner. Alright. So next we're going to say elif traversal type dot lower equals to post order. Then we're going to return self dot post order. We're going to pass in the self dot root and an empty string. We're going to do the slicing the same way we did for the other ones, just to make sure that there's no trailing hyphens or spaces. -3, and then we're going to do again elif traversal type dot lower equals level order. I'm going to return the appropriate method. So this will be self dot level order. I'm going to pass in the self.root and the empty string, and we're going to do the slicing. Alright, so let's see what this looks like. Oh, finally, let's say for example the user passes in the name of a traversal type that it's not contemplated here in this particular method. Then we're going to return a specific message to the user. I'm going to say else. This will be like a catch-all kind of return. I'm going to return a string, an F string to be specific. I'm going to say trav type is not a recognized traversal type, exclamation mark. Alright, and that's pretty much it. Now we can test it. Let's see. Alright, so I'm going to reduce the space here like that. Okay, so inside this print statement here now, well, before I do that, let me just run everything again. Okay, there's an error here. What does it say? As invalid syntax or too many equal signs. again. Alright, I think this time it worked fine. So now, inside this print statement here, I'm going to say tree dot print tree, and I'm going to pass in a string with the name of the traversal method that I want to use. I'm going to start with pre-order, and I'm going to run it, and then we have an output here that's the value separated by hyphens and spaces with no trailing space and hyphens. That looks good. So we go root, left, left, right, then right, left, right. So that looks good. Another cell, another code cell here. Let's see. We're going to try another one. Tree dot print tree. This time we're going to say we're going to use an in order. I'm going to capitalize the I just to show that it should work the same way. And it didn't quite work the way as expected because I made an error here. So it's probably a plus sign missing on the in order method. So let's see. In order method. Here we go. There should be a plus sign right here. I want to make sure the other ones have it. Oh, none of them actually have plus sign. And I think that's pretty much it. Let me just run the whole thing again. And now let's see if it worked. Now it did work. Now we're starting from the leftmost and bottom value 4, 2, 5. Okay, then 1, then 6, and 3, and 7. That looks good. So now another code cell here. I'm going to say print tree dot print tree. This time I'm going to say post order, all capital letters, to see if it works. And it does seem to work. Can't quite see it right now. Let's see. No, that makes it worse. Alright, so it's right there. So let's create another. Okay, good. Now we can see the numbers. So that's a sequence. Starts with a 4, but it has a different sequence altogether. So we're going to do print. We're going to say tree dot print tree. Now we're going to use the level order. We're going to test it. There seems to be an error there as well. Yeah, same thing. There's probably a missing plus sign there. Alright, so let me just go up. Okay, here you go. Missing a plus sign. I'm going to run the whole thing again. Well, let me just check one more thing. Okay, that should be okay. Run time, run all. And then let's see what happens. We have an output of 1, 2, 3, 4, 5, 6, 7 in order. So that's exactly what I wanted. So now, I said in the beginning of the video that I was also going to, the solution would provide a way to search for specific values in the tree. And that's what we're going to do here right now. Defining a method called search tree. And this search tree method is going to take a value that we want to search for and then a traversal function that we're going to use. Alright, so what we're going to do is we're going to be calling this traversal function, one of these functions that we defined up here, and it's going to have an output of similar to what we saw below, numbers. Well, these are all strings, but anyways, representation of numbers separated by space and hyphens. And what I need to do is I need the numbers, but I don't need the spaces and hyphens. So I'm going to have to split this so these numbers are separated by commas, just like in the list, because I'm going to iterate through that list in the code. So let's go back up there. Search tree. I'm going to say values. I'm going to call this list. Values list. That's what it is. And I'm going to call a traversal function. I'm going to pass in the self.root in an empty string, just like we did with all the others. We're going to have to do a slice in here as well. -3. And then the outcome of that I need to split. Since this whole thing here is a string, is going to return a string, I can split that string. I'm going to split that thing, that string on the space hyphen space. I'm sorry. Space hyphen space, just like that. So this way, values list, this values underscore list variable is going to contain the numbers separated by commas instead in the list. Now I'm going to define a variable here. I'm going to give it like an empty string for now. And I said that I was going to iterate through this list here. So what I'm going to do is I'm going to say, I'm going to use a for loop for index, comma. So I'm going to be using enumerate here because I need the index. I want to show the index of the result. What I want to see is a list of true, false, false, true. It's going to return true if that particular value was found in the tree, and it's going to show exactly where in the sequence that value is. I'm going to say num and enumerate, and I'm going to pass in a values list, just like that. Now I'm going to check to see the following. So if num equals the string version of the value that's going to be passed, then I'm going to populate the result. So result equals another string function. So in here, within the curly braces, I'm going to put index. I'm going to do +1 because I don't want the indexes to start at 0. I want the indexes to start at 1. And then I'm going to do colon and the word true, space, and then hyphen space. Too many spaces here. On the other hand, else. So if the number it doesn't equal the value, then I'm going to populate, or I'm going to concatenate the result false to the same variable result. Plus equal, another f string, curly braces, index +1, colon, now I'm going to say false, space, hyphen space, just like that. And now we're just going to return result. I'm going to have to do a slice in result here because we're going to have the trailing space and hyphens again. So I'm going to do the same slice we did before, -3, like that. That's it. Now let's try this. I'm going to say print the results of the search, right? Tree search. Oh, it's not picking up, so let me just run the whole thing. No errors. I'm going to say tree dot search tree. Here we go. I'm going to pass a value. So let's say the value is 4, and then the traversal function I'm going to use is going to be tree dot preorder. So I'm passing the actual function here instead of just like the name of the function. I'm going to run this, see what happens. Well, you can't see the results. I'm going to just create another code cell here. So it's not what I want because it looks like I'm missing a plus sign there as well. So I'll just go check. Let's see. The plus sign is here. So, okay, the result. If number, okay, result equals, plus equals this or that. Let me just remove this here just for now, see what happens. I'm going to run this again. See what the output is. So it's not iterating, it's just going through it once. Why? Don't know. I'm going to have to figure this out. Let's see. Search tree, self value, traversal function. So we're grabbing the whole list. Are we grabbing the whole list here? Traversal function, self.root. Oh, here it is. I'm missing a colon. So let's run this whole thing again. And then let's see what happens. Okay, now it's working. But now we have the trailing space and hyphen and space. So I want to go back and slice it. Remember, I removed the slicing when I was checking to see what the problem was. So all I have to do here is to do this. I'm going to run the whole thing again. Now you have it. So true is a number 3 position. So if you were to pre-order here, I'm going to have to like this. So in the pre-order, 4 is at the third position. So it is at the third position here. So it is correct. Everything else is false. So just to be thorough, let us make sure that the other ones are working as well. So we're going to say tree dot search tree, and then I'm going to pass 4 again just to for comparison's sake. I'm going to say in order. Let's see the result. And then again, for the in order, 4 is the number 1 position, and it is here. Everything else is false, so it's working properly. I'm going to check the other one, tree dot search tree, and then I'm going to pass in the value 4 to be consistent. Tree dot, and I'm going to say post order. I'm going to run it. I'm going to create a space here. So again, 4 is the number 1 position. Everything else is false, just like in the post order calling that we did here. Okay, so now let's try level order. Print tree dot search tree. We're going to pass in the value 4, and then as a traversal function, we're going to say tree dot level order, and we're going to run it. And here it is. So level order 4 is right at the 4 position. 1, 2, 3, 4 position is true. Everything else is false. That's it. So yeah, this is the end of this code. Again, it's an object-oriented solution to how to create a hierarchical data structure in Python, and how to traverse through this structure and check values or collect values from each node. And that's what this does. I know this is a long video. I was going to actually split it in 2, but then I got lost here in the time, and I didn't cut the video short when I should have. So I apologize for the long video, but I think it's a more complete picture of how to do this here. That's it. Until next time.